Welcome back. First one I'm going to do is a geometric sequence application. It says my car depreciates approximately 10% each year. If I bought my car for $20,000, so A sub 1 is $20,000, how much was it worth at the beginning of the 16th year? So I want to find the 16th term. I like to be a positive person. Instead of saying that I'm going to subtract out 10% each year, I like to say if I'm losing 10%, that means I'm keeping 90%. So I'm going to use my formula for a geometric sequence, and I'm going to substitute in our values. 20,000 is my starting. My R value, what I'm multiplying by, what I'm keeping is 90%. And N for my 16th term is 16 minus 1. Type that straight in. $4,117.82. And that is my geometric sequence application. Next, I want to do two examples with geometric partial sums. You'll see I have the formula up here at the top. Zoom in a little bit so you can read a little easier. Okay, I look at these sequences right here, and I can easily find the three things that are missing in the formula. I shouldn't say missing, that are variables in our formula. I have A sub 1 is 2. My R value is 6.5. And my N, since I want the 10th partial sum, is 10. So I will simply substitute into the formula. A sub 1 is 2. 1 minus my R value, which I like to put in parentheses, even if it's positive, which you don't have to. I just feel better with it in parentheses because if it's negative, I definitely need it, to the 10th power. Then I close it. Please note that this exponent is inside that last parenthesis over 1 minus 6.5. You can do alpha y equals, type that straight in, maybe do the numerator and then the denominator separate and divide them out. And when you do, you get a big number, and that number is 489555429.98. The other one we have here, it says I want the 12th partial sum. I can see here that I have my three things pretty easily. A sub 1 is 6. My R looks like it's -4. If I multiply by -4 each time, I get what they have there. And it said I wanted the 12th, so N is 12. So I'm going to write the formula again so you can see it. The equals look a little better. Then I'm going to substitute in the information. 6, 1 minus, my R value is -4, raised to the 12th power, then close my parenthesis on the top. On the bottom, 1 minus my R, which is -4. So when I do that, maybe I want to put the top in, and I'll get -100663290. The bottom is 5, and if I divide that out, I'll get -20132,658. And that is basically how you do your geometric sequences, sums. So let's do a few extras here that are written a little differently. Okay, these are the same thing except for I have sigma notation. If I see something being raised to variable power, exponential here, that lets me know that it is geometric. So I'm still going to use the same formula. I'll write that on here. And I'm going to list the A sub 1, R, and N for each of these. So if I look at the first one, always plug this value in to find the first term. So 3/4 to the first power is 3/4 times 8 would be 6. So A sub 1 in this one is 6. R is whatever's being raised to the power. And in this case, I'm adding 17 numbers, so N is 17. Those will be the numbers that you use in this equation for that one. I'm not going to take the time to put those in. You can do that on your own. I just want to check the other two. In this one, my three things, I'm adding the first through the 17th term. That's 17 numbers again. My R is 3/4. Always plug in the lower index to get the first term. 1 minus 1 is 0. 3/4 to the 0 power is 1, and 1 times 3 is 3. So those would be my three variables for the formula here. The next one is a little tricky. Again, I would need these three things. Weird to start with a 0, but sometimes they do it. Negative 2/5 to the 0 power is 1. 1 times 1 is 1, making my first term in that sequence that I'm adding up a 1. R, again, is the number being raised to the power, which is negative 2/5. And N, if I'm substituting in the numbers 0 through 8, 0, 1, 2, 3, 4, 5, 6, 7, 8, that ends up being 9 different terms that I'll be adding up. So be careful. Rarely does this happen, but if they start with a 0, there will be one extra term. So take those a sub 1's, r's, and n's and plug them into the formula, and that's how you would do partial sums of geometric sequences.